All right, hello boys and girls. So here is your math lesson for today. So what we are doing in math today, we are subtracting numbers with more than 3 digits, and we are doing word problems about equal groups part 2. Okay, so I'll give you a second to write that down. You can always pause me if you need me to go slower. I am limited on the time I have on these videos. All right, so feel free to pause because I know that is a lot to write down. But we're going to go ahead and keep going. All right, so when we just solve subtract a number regularly with more than 3 digits, we begin by subtracting in the ones column, regrouping if necessary, which is also another way to say borrowing. Okay, then we move one column to the left, subtracting the tens, again regrouping, then the hundreds, then the thousands, and the 10,000s, etc. Keep going. Sometimes we must subtract across several zeros or borrow across several zeros. All right, so we're going to do some practice problems. 36,152 tickets were sold for the first baseball game of the year. 9,415 fewer tickets were sold for the second game of the year. How many tickets were sold for the second game of the year? So here's the keyword. It says 9,415 fewer tickets. It does not say 9,415 tickets were how many that were sold, but it says that many fewer were sold for the second game compared to the first game. So that is a keyword that tells us we're going to be subtracting. So first, I need to write those numbers down. So it says 36. Remember when we say 1,000, we put a comma. 152 tickets. I'm going to write the word tickets. So I remember to label. Were sold the first game, and then 9,000, so 9 comma 415 were sold the second game. So fewer tickets, 9,415 fewer. All right, so we are going to subtract. Okay, so we cannot do 2 minus 5. So we have to borrow from our 5. 5 becomes a 4. We add 10. Our 2 becomes a 12. 12 minus 5, take away 5 is 7. 4 take away 1 is 3. Okay, I cannot take 1, take away 4. So I have to borrow from my 6. 6 becomes a 5. And my 1 becomes an 11. So now I have 11 take away 4, which is going to give me 7. And I bring my comma down. I cannot do 5 minus 9. So I take away from the 3. Then my 5 becomes a 15. 15 minus 9 is 6. And 2, take away nothing, is 2. Okay, so then the question says, how many tickets are sold for the second game of the year? So then to rewrite this, 26,737 tickets were sold the second game. Okay, simple enough, but make sure you are reading story problems carefully. That's where we get tricked up. We might think, oh, well, there's 9,415 tickets sold the second game. No, it says fewer, so we have to read the words very carefully. All right, so a charity received a contribution of $5,000. In the first month after the contribution was received, the charity spent $2,386. How much of the contribution remained after the first month? So that's how much they spent. So there's that word spent. That means we're taking away again. Okay, so they received $5,000. So there we have our zeros. I'm going to put a dollar sign. They spent $2,386. Okay, so we're going to have to borrow a few times here. You can't do 0, take away 6. Can't do 0 minus 8. Can't do 0, take away 3. So we borrow from our 5. 5 becomes a 4. Then our 0 becomes a 10. But here's the issue. This one also needs borrowed. So then we take our 10 out. It becomes a 9. 0 becomes a 10. But we need to make this guy bigger too. So then we take away from our 10. It becomes a 9 until we are at a 10 for our last digit. 10 take away 6 is 4. 9 take away 8 is 1. 9 take away 3 is 6. 4 take away 2 is 2. So we have $2,614 remained. That's how much they had left. Okay. So As long as you take your time, you will be able to solve these and just pay attention. Remember to borrow, regroup as you go. Okay. All right. Get that zoomed in. There you go. Equal groups word problems have a multiplication formula. If we know the number of groups and the number in each group, we can multiply to find the total. However, if we know the total, we have to divide to find the number of groups or the numbers in each group. So I'll show you what that means. Okay. So Marvel has 21 tennis balls in cans. There are 3 tennis balls in each can, so we have to figure out how many cans he has. All right, so there are 2 numbers. The words in each are a huge clue. They show us that the number of objects in each group is 3 tennis balls. The other number is 21. That's our total number. Because it says altogether he has 21 tennis balls, so that is our total. So here's what our formula will look like. So I'm going to put in each group, and I'm going to write the number symbol. So the number in each group times the number of groups is going to give us our total, okay? So in this problem, we have 3, oops, you can't see it. All right, so in this problem, you have 3 tennis balls, okay? That's in each can. Number of groups, we don't know how many, so I'm going to write N. We don't know how many cans, that's what we're finding, and we know the 21 is the total tennis balls, okay? So to find this N, we have to divide 21 divided by 3, and that's going to give us 7. Now we need to check it, just like we learned yesterday. 7 times 3 equals 21, check. So the question says, how many cans does he have? So then we can just put M has 7 cans of tennis balls. Okay? All right, we're going to do another problem. Hey, Trishna has 5 large cans of racquetballs. She has 40 racquetballs in all. If each can contains the same number of racquetballs, how many racquetballs are in each group? So the words in each show us that it's an equal group problem. However, we are not given an in each number, so we do not know the in each number. That means we are trying to find it. Okay, so here's our formula. So we have our number of groups times our number in each group equals our total. Once again, okay? So this time we have our groups. We have 5 cans. We don't have our number of racquetballs in each can. So we just put an N there. And then we do have our total is 40 racquetballs. We really like their sporting equipment. Okay, so we can take 40 divided by 5. That's going to give us 8. And then we check it just to make sure. 8 times 5 equals 40. The question says, how many racquetballs are in each can? So we have to remember, this is the number we were looking for, not this. We already had that. So then we would say 8 racquetballs in each can. And another way you could write this kind of problem, and we've seen this before, 5n equals 40. So you can also write it that way. That shows that it is in each problem. You're welcome to do either way. All right. Marcia found a length of fabric marked 16 feet. She needs 4 yards of fabric to make a costume for a school play. Can the costume be made from the length of fabric Marcia found? So we need to figure out if it's enough. If you notice, the fabric is marked 16 feet. She needs 4 yards. Feet and yards are different measurements. So we have to convert 16 feet to yards by dividing 3 because there are 3 feet in a yard. Okay. 36 inches 3 feet in a yard. But 16 does not divide evenly by 3. So we're going to look for a nearby number that's compatible with 3. So instead we choose to divide 15 by 3 because we are just trying to see if she has enough. So 15 divided by 3 is going to give us 5. So we find that 16 feet, and this is a symbol for about the crooked or swervy equal sign looks like. 16 feet is about 5 yards. So there is enough fabric to make this costume. Okay, in this situation. All right, we're going to do one more, actually we'll do one more subtraction and one more equal groups problem. All right, so we're going to do 4,000 minus 527. Because of these zeros, I just think it's good to see another example. So we can't do 0, take away 7. We can't do 0, take away 2. We can't do 0, take away 5. So we have to go all the way to the 4. 4 then becomes a 3. Our 0 we've borrowed, so 0 becomes a 10. We can't subtract yet, though. 0 becomes a 10. Can't subtract yet, though. 0 becomes a 10. Now we can subtract. 10 take away 7 is 3. 9 take away 2 is 7. 9 take away 5 is 4. 3 take away nothing is 3. So we have 3,473. All right, now we're going to do one more equal groups. We'll just do this first one up here. There were 35 people. There were 7 cars. The number of people in each car was the same. So there's that in each. How many people were in each car? Okay, so we have our total. The total number of people was 35. Right, so I'm going to put that at the bottom. We don't have our in each number, so I'm just going to put an N there. And we know there were 7 cars. So this is kind of how that would set up. What we're going to do to find our in each is divide 35 by 7. That's going to give us 5. 5 times 7 is 35. So we just got to check it. And then it says how many people. So we have found there were 5 people in each car. So you have to make sure to label. We have to make sure it's reasonable. Does it seem reasonable to have 5 people in a car? Yes, right? That's a reasonable number. If we said, oh, it's 20, is that a reasonable number for a car? Not a bus, not a big van, but a car? No, right? 20 wouldn't make sense, but 5 makes complete sense for a car. All right, so that is your math lesson today. You're doing the odd problems on pages 334 through 336.